In 3.4a, our first video, in this section we will be solving inequalities. And an inequality, if you remember, is going to be something that has less than or equal, greater than or equal. I've got good news for you. If you can solve an equation, you can solve an inequality. So recall, before we move on, it's very easy to determine which number is smaller or greater on a number line because the numbers to the left are smaller, and as numbers go to the right, they get bigger. So how would A and B compare? Okay. A is less than B, and another way you could say that is B is greater than A. How do B and C compare? Well, B is less than C, it's to the left on the number line. Likewise, C is greater than B. And if we want to, we can compare A and C. A is less than C, and C is greater than A. So if in doubt, especially when you get into those negatives, think about where things are on the number line. Okay, mathematicians, we are going to make a discovery. So we're going to do an experiment. In each case, we're going to start with the inequality, and we know that 4 is less than 10. So we're going to start with that in any case. So what I'm going to ask you to do is add 2 to both sides of that inequality, and I've done it for you. So when we add 2 to 4, we get 6, and when you add 2 to 10, you get 12. And what is the inequality? How do those two numbers compare? Well, it stays less than. So keep that in mind. When we added something to both sides, the inequality direction didn't change. Next experiment, mathematicians. Starting with 4 is less than 10, we're going to subtract 3 from both sides. What are we going to get? 4 minus 3, 10 minus 3. And how do those two compare? Well, 1 is less than 7. So again, subtracting the same number from both sides didn't change our inequality at all. So let's see what else we've got here. Now let's try multiplying and dividing. Multiply both sides by a positive 3, we would get 12, and we would get 30, and well, it's still less than. So multiplying both sides by a positive number didn't change anything. 4 is less than 10. Divide both sides by 2. 4 divided by 2, 10 divided by 2, still less than. So you're probably thinking, well, so what? What was the whole experiment about? So let's now try multiplying and dividing by a negative. So when we multiply both sides by a negative 3 in this case, we would get a negative 12 and a negative 30. And think about where you are on the number line. Here's 0, we're going to the left for negative, so we would hit negative 12 first, and then we would eventually get to negative 30, so we go, uh-oh, negative 12 is greater than negative 30. So something kind of exciting happened there, mathematicians. When we multiplied by a negative 3, we changed the direction of inequality. Let's see if anything happens interesting when we divide both sides by negative 2. So 4 divided by a negative 2 is negative 2. 10 divided by a negative 2 is a negative 5. Think on your number line. Here's 0. We go to the left to get to our negatives. We'd first come to negative 2, and then we'd hit negative 5. So negative 2 is greater than negative 5. So mathematicians, we discovered when you divide by a negative, the direction of inequality changes. So there is a moral to this story, mathematicians. You can, when you have an inequality, you can add or subtract anything you want from both sides, as long as it's the same, and the inequality stays the same. Likewise, you can multiply or divide, but if it's by a positive only, then the inequality stays the same. So that's not very interesting. It's the second part that gets kind of fun. When you multiply or divide by a negative, that's when the direction of inequality changes. So it's only when you multiply or divide, and it's only when it's by a negative number. Okay, pretty soon here we're going to have to solve some inequalities, and like I mentioned at the beginning, solving an inequality is exactly the same as solving an equation, except when you multiply or divide both sides by a negative number, you've got to remember, change the direction of that inequality. Okay, let's take a look at, whoa, we lost our page here. Well, you can see what's coming. Okay, one thing that I want to point out, final answer should be in the form. So you're going to have, on the left-hand side of your inequality, you're going to have the variable. In this case, it's an x. And on the right side of the inequality, you're going to have just a lone number. And then your inequality, whether it's less than, greater than, less than or greater than or equal, is going to go in the middle. But the important thing to remember is you want that variable over on the left-hand side. And if it's not, you just pick it up and turn it around. It's very easy to take care of. So let's take a look at some examples. We are ready for number 1. Okay, so you guys would know how to solve. Let me just do this over on the side. Negative 2x plus 3 equals 5. So let's just review that very quickly. What would we do to get x all by itself? Well, the first thing we would do is subtract 3 from both sides to give us negative 2x equals 2. Then, to get rid of that negative 2 in front of the x, we divide both sides by negative 2. The result is x is equal to negative 1. So if you know how to do this, you know how to do the inequality, just with that one exceptional time when you've got to switch the direction. So I'm ready to go. To solve this, do the same thing. Subtract 3 from both sides. Negative 2x less than or equal to 2. We didn't change the direction because we subtracted. We can subtract all we want. It's not going to change the direction of the inequality. Now, to get that x all by itself, we have to divide both sides by a negative 2 and beep, 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 beep. When I hear myself saying I'm dividing by a negative both sides by a negative 2, I go, okay, that's going to switch this direction of the inequality. So the left, negative 2 divided by negative 2, that's where we get our 1x. This side, negative 2 divided by negative 2 is negative 1, and there's our answer. So what this is saying is any number that's greater than or equal to a negative 1 will work in our inequality. So there are an infinite number of answers, and anything works as long as it's greater than or equal to negative 1. Okay, next one, very quickly here. To solve this inequality, it looks exactly the same, but we've got more negatives at different places. So we're going to add 3 to both sides. 2x less than or equal to negative 2. Divide both sides by 2. X, negative 1. Do we have to change the direction of the inequality? Well, what did we do to get from this step to this step? We divided by a 2, but it's a positive 2, so the direction does not have to change. So that is our answer, which means any number less than or equal to a negative 1, to the left of negative 1, is going to make our original inequality work. I think we have time for one more example. Okay, so there's a little bit more to do here. Just like an equation, let's go ahead and clean up the left-hand side. And I'm going to say, and do you notice what I did here? To clean this up, I used the distributive property, which is multiplying by negative 2. But I'm only using the distributive property. I'm just cleaning that side up. I'm not multiplying both sides by a negative 2. So nothing, the direction of the inequality doesn't have to change. So very quickly, negative 2x minus 5 greater than 7. Add 5 to both sides. And divide by a negative 2. Ding, 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 ding. When we divide this side by a negative 2, we get an x. When we divide the right-hand side by a negative 2, we get a negative 6. But since we divided by a negative 2 both sides, we have to change the direction of the inequality. And we will continue with more examples in the next video.